Paper calculus today. Look at vector direction. Loading target for today is you'll be able to find the direction angle of the resultant vector. So we usually start with do now, and so I just found out that Crudes 2 is coming out next, 2 months from now. The Crudes is one of my favorite movies. Um, so here's a problem: it's got Eep from the Crudes in there, and she measures distances in mammoth lengths because you got to use what you got. So here's a right triangle. We find the indicated angle. She's Eep's already counted it out. 54 mammoths on this side and 33.1 mammoths on this side. Um, okay, go ahead and hit pause on the video, and I will wait for you to calculate that indicated angle. Okay, so hey, welcome back to me. Um, So I don't know if you guys remember learning, maybe you didn't actually learn SOHCAHTOA, but sine, cosine, tangents, and geometry. So we got a right triangle in the do now, and we're gonna figure out which sides we're using. If we can figure out which sides we're using between opposite, adjacent, and hypotenuse, that'll give us you can tell us which of the three trig ratios here we ought to be using. So I went ahead and labeled the sides already. The hypotenuse is always going to be the long side. It's opposite from the right angle. And based on where Eep is standing is how we determine whether it's the opposite or adjacent side. So the side next to Eep is going to be the adjacent side. Obviously the side that's not the hypotenuse, which is next to her. And then the side at the opposite side, opposite end of the triangle is the opposite. So we got measurements for opposite and adjacent. And if we know the opposite and the adjacent, we can use tangent, regardless of how the triangle is situated on the page. Um, here's our indicated angle. That's like where Eep is standing. And down here is a different possible version. If you're talking about this triangle or this angle up at the top part, the opposite would be down there and the adjacent would be here. The adjacent is always going to be next to the angle. Okay, so we've got tangent, right? Based on where Eep is standing, adjacent, opposite. So I could set up a trig ratio and solve to find theta. So I dropped opposite on the top, adjacent on the bottom, tangent. The tangent ratio is opposite on the top, adjacent on the bottom. I don't think I pointed that out over here, but here's the ratio right there. Tangent is a name given to this ratio. It's the ratio of the opposite side to the adjacent side. Okay, so I went ahead and divided 33, but you weren't watching. It was on the other screen. I pulled up my calculator, divide 33.1 divided by 54, and I got 0.61. And in order to find out what angle that's going to give me, I need to use the inverse tangent on my calculator. It means I got to hit second or shift and then the tangent. We write it on paper using the little like -1. It looks like an exponent. It's not actually an exponent, but sure looks like one. So the inverse tangent of 0.61, and I got 31.5 degrees, and that's the angle. Now Eep knows how high to aim. I don't know if Eep actually aims anything. I've never seen her aim. Just like hitting things with rocks. Yeah. All right. Hey, well, so that is using right triangle trig, the tangent ratio. That is something that's would be absolutely essential to what we're doing today. Um, if we think about it, if Eep were standing at the origin on a graph, if we just draw an x and y axis on here, um, if she's at the origin, we've got a triangle. The blue 54 mammoths, that's like an x component, and this 33.1 mammoths, that is like a y component. The hypotenuse is like a resultant vector. And if you think one step further, what that means, regardless of the triangle, if you have component form, if you've got an x component and a y component, the trig ratio you're going to want to use to find this angle is always going to be tangent. All right. So in order to find the direction angle of a vector, we need, first of all, to use tangent like we talked about. And second of all, we got to remember what you see here in this picture. This is the definition, well, it's a description of what direction angle looks like on a graph. So it looks like I don't know, like a bullseye or something with a swirly going around there. It's not. It's an x-axis. It's a y-axis. 0 degrees is over there. Rotate counterclockwise. 90 degrees is going to be straight up. Oh, rip your shoulder out of socket. Can't get there. 180 degrees is going to be straight over there. Keep going around. 270 is going to be straight down, and then switch arms. Bring it back up. 360 is the same place where you started. Okay, so the little arrows in here are telling you which direction we go around the circle to get bigger numbers. Starting at 0, you go around. I can't do the mouse and my arm motion at the same time. Go around this direction, you get bigger numbers. Okay, that combined with the use of tangent is pretty much all we need to be able to find the direction angle of a vector. So let's go to the, whoops, that's the wrong button. Let's go to the next page. We're going to try some problems here. I'll let you see them all. We're going to do them one at a time. So we're going to find the direction angle for each vector shown. This doesn't involve any tangent right now. We just got to figure out how to wrap our heads around this direction angle business. So in each of these cases, I've already given you the magnitude and the sort of direction. I gave you an angle. It's not the direction angle, but I gave you an angle measurement of some kind between the vector in blue and some part of the graph, either the x-axis or the y-axis. So your job is to figure out what is the direction angle. Okay, so go ahead and hit pause on the video. See if you can figure out direction angle for numbers 3, 4, 5, and 6. I'll just stare out the window. Okay, so welcome back to me. Thanks for finding those direction angles. So I am going to look at, here's our directions, just one problem at a time. So I hit over here a small version of that kind of the unit circle with the direction angle, and I'm just going to overlay that right on top of each of these graphs. So here's what we're going to pay attention to. The vector is given with an angle, and it's marked from someplace, right? So we got to figure out where is it marked from, and which direction is that little measurement arrow pointing. In this case, it is pointing the wrong, it's starting from the, like where 360 is, or 0 degrees, and it's pointing the opposite direction, right? If I start from the positive side of the x-axis, in order to rotate the shortest possible way to get to where that vector is, I had to go against the flow of these little swirly arrows, right? So that means I'm going the opposite direction. Opposites are always negative. Okay, so I'm going to subtract. Since this measurement started from on my unit circle, started from where 360 degrees is, and I'm going the opposite direction, I'm going to subtract 360 minus 28. And some quick mental math is 332. Okay, let's take a look at the next one. So this one, we've got a 64-degree angle measured there, but this is from the opposite side of the x-axis. It's like the negative side of the x-axis. Let me bring my overlay. Okay, so to get from that part of the x-axis, would that be over here, right? Down to where that vector of 79 inches is at, I'd have to rotate in the correct direction. That's the same way direction angle goes. It's counterclockwise, same direction I can add, right? Match up which angle is along the negative part of the x-axis. That's 180 degrees right there. And so I'm going to add the 180 plus that 64 since I'm going the same direction. And real fast, the mental math, 180 plus 64 is 244. Okay, well, let's do another one. Number 5. Okay, so this one is measured from the positive part of the y-axis, and the angle was measured from the positive part of the y-axis in the counterclock. Sorry, doing the wrong thing. It's in the clockwise direction, going back towards where we should have started from. if I uncover the arrow, I can actually see where the little arrowhead is. It's pointing the wrong direction. Okay, the wrong direction, the clockwise direction, means subtract. And that measurement lines up from where 90 degrees is. So I can take 90, subtract that 22-degree measurement, and that is going to give me the direction angle. 90 minus 22, 68. Okay, let's do this last one here. So this one's kind of weird. Look, it's like measured from, that's weird. It's measured from like the negative part of the y-axis, and then it crosses over the x-axis to get to where the vector is at. That's a weird thing. All right, well, I'm going to bring my overlay on top of this graph. So that measurement starts from straight down on the negative part of the y-axis, which would be 270 degrees. And then the rotation to get from there to the vector, so like straight down, whoop, up here to the vector, is going in the wrong way. It's going clockwise. That means subtract, right? So 270 minus 117. And of course, everybody knows 270 minus 117 is 153. That's like, that's like right up there with 2 plus 2. Everybody knows that. Just like, gosh, you don't even have to think about it. I'm kidding. I'm sorry. Sarcasm and videos is maybe not a good mix. Anyway, but we can subtract and figure it out. Yeah, so we need to jump back and revisit Eep's triangle. So last time we were here with Eep, she had found, or we had found the angle, 31.5 degrees. Okay, so I labeled it. There's our 31.5 degrees, and I also drew in this little measurement. So showing the direction that I'm going. Okay, I always refer to this as the inside the triangle angle because it's inside the triangle. Like I guess that makes sense in somehow maybe, I don't know. So when we're drawing triangles onto a graph, always make sure one of the sides of your triangle lines up with the one of the axes. Okay, the x-axis, the y-axis, but one side of the triangle is going to line up on an axis. One of the components will line up on an axis, right? So we try to keep that on the x-axis by convention, x. And we're going to draw this little arrow that shows the direction we measured, starting from the x-axis, and then whichever side way you got to rotate to get from that x component side to the resultant. Okay, so in this triangle, the x component is 54 mammoths, but that lines up on the negative side of the x-axis, and we had to rotate backwards, clockwise, to get to the hypotenuse, right? So there's our 31.5 degrees with our direction indicated. So that's not direction angle, that's just like, that's inside the triangle. That's the direction you had to go to get from the adjacent side up to the hypotenuse. Okay, next, Eep has in her back pocket a unit circle. Who knew that cave women had these? So I'll overlay this right on top of my x and y axis, and so I can see the side of the triangle here lines up with where 180 degrees is. It's the negative side of the x-axis, and the direction angle rotation is going counterclockwise, but on my triangle, the red arrow here is going clockwise. Opposite always means subtract. And so I'm going to need to start from 180 degrees, subtract the 31.5 degrees, that's the inside the triangle angle. That will give me my direction angle. Okay, so I got some workspace down here. So I took my 180, I subtracted the 31.5. 148.5 degrees is the direction angle. Okay, so 148.5. If Eep had started from the positive side of the x-axis and measured her angle all the way around to that vector, you kind of get a sense of the angle between my hands there. 148.5 degrees. There it is. Okay, so remember, stay inside the cave, follow the rules, otherwise you die. That is essentially everything you need to know. I think you'd be able to get started on the assignment. I will put up another video with some examples from the actual assignment, but good luck.